Hello and welcome to the section on machine learning in Spark. In this section, we will learn how to perform data modeling and machine learning on an example of the houses prices prediction. This section consists of two parts. In the first part, we will be covering the architecture of the Spark machine learning module. In the second part, we will have a more deep view at the algorithms used in Spark. We will have a look at the theory behind their design and usage, as well as the practical example of how to do that. By the end of the section, we will have two machine learning models fit to predict houses prices based on their features. Let us start from the overview of the architecture of the Spark machine learning module. In this video, we will cover two aspects. First of all, we will have a look at the Spark machine learning architecture from the bird's eye perspective. Then we will start to zoom in and have a look at the core classes that Spark machine learning module uses to support the entire architecture of itself. At the highest level, Spark machine learning API can be divided into two parts based on the type of the data structures it works with. Let us recall that Spark represents data in two ways. First is resilient distributed datasets, or RDDs, and it is good for parallel and distributed processing. Second way is SparkSQL. It is used for SQL-like data access and representation. This duality in data representation drives the duality of the Spark machine learning module. As you can see, this module consists of two parts. First part deals with RDD-based collections, and the second part deals with SparkSQL-based collections. So you should select Spark machine learning module based on the type of the collections you are working with. Since in this course we are covering only SparkSQL-based data structures, here we will also focus on the Spark machine learning API for SparkSQL data structures. Now let us have a look at the machine learning module architecture that Spark provides. And I believe the best way to do so will be to have a look at the Spark API documentation. So let us do so. So first thing to notice here is that Spark machine learning module consists of two major packages, the ML package and MLlib package. So the ML package is used for machine learning operations on the SQL-based data structures, whereas MLlib module is used for the machine learning on RDDs. So we will be focusing on the ML package. So the top-level ML package is the base package that defines some commonly used classes, and highest-level package that defines some commonly used classes and the classes that represent the highest level of abstraction of the machine learning concepts used in the module. So as you can see, it has some classes that are used throughout the entire module. Next set of packages that worth noticing are the packages that contain machine learning algorithms themselves. These are packages like classification, clustering, regression, and recommendation. So as you can see, all the machine learning algorithms are grouped in packages depending on their purpose. Another package that we will be dealing with during this course is the evaluation package, and it is used to evaluate the performance of your model over some dataset. Feature package is something that we have already covered in the previous section, the section on feature engineering and feature transformations. It contains various classes that are used to work with features. Finally, another package that we have already encountered during this course is linalg, or linear algebra package. It contains implementations of vectors and matrices that you can use with Spark. We will not be covering all the packages available in the Spark machine learning module, we will only focus on the packages that we will be using for our examples. Because different packages have tools for different tasks, so whenever you have any machine learning task different from the regression task that we will be doing, you should always consult the API to determine which tools you need. Set of entities to cover will be the contents of the core ML package. The reason we are focusing on this package, it contains the abstractions that are used throughout the ML module and are used to define all the other classes, so it is useful to know what it contains, what are the basic abstractions, and how to use them. Let us start from the transformer class. In fact, we have encountered the instances of the transformer class in the section on feature transformation and feature engineering. Basically, the most interesting thing in this class is the transform method. The transform method takes a dataset and transforms it to another data frame. We have already seen how it works on the example of, for example, feature scaling, when we scaled a vector of scalar values to have certain statistical properties. Another class to have a look at is the model class. As you can see, the model class is the subclass of the transformer class, meaning that it is used to transform one dataset to another data. The model in Spark represents the result of the work of a machine learning algorithm. And the transformation the model does is the prediction of a value based on the features stored in the dataset. So most often a model adds another column with the predicted values to an existing dataset when you call transform on it. Next class to have a look at is the Estimator class. An Estimator class is the base class for all the machine learning algorithms available in Spark machine learning module, and the most interesting part of it is the fit method. So as you can see, it runs on the dataset and produces some value of kind m. And as you can see here, m extends a model. So basically, what Estimator does is that it runs on a dataset to produce a model that is capable of doing predictions over similar datasets. Finally, another interesting class to have a look at is the pipeline class. A pipeline is a simple way to group several estimators to run in sequence without the need to write a lot of boilerplate. So this concludes a brief overview of the architecture of the Spark machine learning module for SparkSQL API.